Hello, Ania. How are you?
I'm good. How are
Good. How
you?
are you? Good. I will be starting in a few minutes. Um, just in a few minutes.
Okay.
So I think we can start. Oh, others will join us later. You dear Ania. Hello.
I'm here.
Okay. So let me share my screen and then we can begin. And you remember this table I mentioned. So try and download it because, like I said, we'll be using it from now onwards. So now let us begin. Let me have where we stopped like yesterday. So now I've shown you in the class last Wednesday how to get all this. Now sometimes you'll be required to find they will give you the probability and other information. They will ask you to find a specific or a data value. That's the X part of it. How do we do it? So in that case, you use this formula called X equals the Z value times standard deviation, which we can get from 1 minute. Standard we can get from the symbol in certain symbols, which is this plus the mean, and that will give you the data value you are looking for. So the Z value they gave you, well, they will not give you the Z value, but they will give you the probability. Then you can use that probability to get the Z value. They will give you the standard deviation, they will give you the mean, and they give you the probability. They will ask you to find the X. So let's see how this works. In this example, we have, it says here, to qualify for the police academy, candidates must score in the top 10%. See, they give you the probability, top 10%. And on a general ability test, the test has a mean of 200 and a standard deviation of 20. Find the lowest possible score to qualify. Assume the test scores are normally distributed. So again, knowing that we are going to use this formula, first thing we do is to draw our chart. So I'm going to put solution here. So we are given the mean. We're given the mean and we're given the standard deviation. Okay, so we're given the mean as the mean is 200. Standard deviation is given us 20. So, and the probability they gave us, they say that is 10%. So, let me put it in this form. Let's draw the chart first. And from there, we can figure out what we can put for the 10%. So, starting from here, we'll go this way. Okay. Okay. All right. Just 1 minute. 1 minute. Okay. Now we can now put other information in the chart. Put the x-axis and the center, which is 0. That's the mean of 0. And so it's 0 here. Now we're looking for Z. It's a top 10%. So you start from, let's say the start from here, 0. This is the center. If suppose there's no 0 here, I'll begin from 0 and then, well, even if it's 0 here, it doesn't really matter. So let's say they have 0 here, to all the way to 50%, you know, but it's a top 10%, top 10%. So assume that we started from this side as 0, go all the way to, because 0.5 and 0.5 give us 100%. So that means top 10% should be around here to get to the 100%. So now we have do this way, put the drawing from here, and this is the top 10%. This, I mean, this the whole of this place is going all the way down, it will be 90%. Then from here up to go to 100. So this is the top 10%. So we shed it. And then we're gonna shed it. So this one is located at the tail. Okay. All right, last one. Okay, so this represents the top 10%. 10%. Okay, it's gonna be from here, right here. Okay. So now, so let us figure out what is the z value for this 10%. So that our z will become, now remember I told you when it is at the tail, you subtract from 0.5. But in this case, we're doing the opposite. So we're gonna do 0.5, because we have the minus, actually it's the same thing, 0.1000, because 10% is 0.1, it's 10%. So once we have this, we subtract this in the calculator. And with Desmos calculator, we have that, what is it? Okay, right here, 0.5, 0.5 minus 0.1. I clicked something by mistake. So, okay, good. So 0.5 minus 0.1, 0.1, it was 0.4. And because this is four digits, there are 4 decimal places, so it's going to be 0.4000. So I'm going to go back and put it in. So you can have it here, 0.4, 0.4000. Now, we're going to look for this in our table to get the corresponding z value, okay? Which is, so we go to the table and look for 0.4000. Now, if you don't see exactly the number that is 0.400, we take the one that is closest to it. So taking you to the table, which is here, start looking for 0.4000. Let me make this a little bit bigger. Okay, 0.4000. So you can see, 1 minute. Yep, it should be better. So we have, look inside the table. We have 0.4015 and 0.3997. These are the closest. So these are the two numbers that are close to 0.4000. So let's see which of them is closest. So I'm going to write, let me write them down. We have, first one is 0.399, 0.3997, and the second one is 0.4015, So I will look at them as whole numbers. That make it faster for us. And then we can see which of them is closer. So I'm gonna go take you to the paper. So suppose we try it here on this section. I have let me do it on the rough side of this. We're looking at point 0.4, excuse me, 0.4000, which is what we are looking for here. Now, and then we found two numbers, 0.3997, and the second number we found was 0.4015. So let us check which of these two numbers are closer to this 0.40. So look at them as whole numbers. So we're gonna do 4,000 minus 3997. So I'm gonna do of course you know that 4,000 by 4,000 I mean 0.4. So 4,000 minus 3997. See, it's 3 points away, only 3 points. But the other number may be 4015 minus 4,000. Okay. So I have so we're gonna clear this 4015 minus 4,000. This one is 15 points away. So it's far away when compared to the other one. So the other one is only 3 points away, which means we're gonna use the one that is on only 3 points away, which is this one. See this one. So we go to the table and take this one. So on the table, if you look at our table, you will see 0.3997 is right here. Now, when you follow it to the left to find the Z, see, it's got the Z right there. So see, this is the Z right here. So when you follow it to the left, 1.2, and if you follow it up, see 8. So what was 1.28? The Z value becomes 1.28 from the table. 1.28. Now, so we have all the information we need. Now we're going to apply the formula to find our, because the question was asking, find the lowest possible score to qualify. So this is the formula X equals Z times standard deviation plus mean. We are given the mean as 200 and standard deviation as 20. Now we have the Z as 1.28. Okay. So we're gonna plug them in the formula and get our answer. So that our X, the lowest score to qualify, lowest score to qualify for this, which is our X, equals Z times standard deviation, which is let me get a symbol from here, then plus the mean. Z times standard deviation plus the mean, which means our Z is 1.28 times standard deviation of 20 plus the mean of 200. So let me write it down, and then we can go to decimals and get this out. So 1.28 times standard deviation of 20 plus 200. This is times, by the way. Make sure. Times. Okay. Now I'll take you there and get it out to the calculator. So we have this as 1.28 times standard deviation of 20 plus the mean of 200. So 225.6. So the lowest possible score, the score to qualify, would be 225.6. 225.6. Any question for me on this?
No question.
Okay. So this is when you have to do the opposite. When you have to find the S value. Mr. Aaron, okay, you are here. Okay. Have you emailed me your work yet?
No, not yet. I was doing all of the other work before just so I didn't fall behind on that work yet, you know?
So probably by Sunday it should be ready, huh?
By Sunday, I can get it done by Sunday.
Okay. Okay. So then
All right.
I'll need it that time. Yeah. All right. So let's see this. Now, sometimes they might ask you this kind of question in a different form, and then it's still the same process. Use the probability that they gave you to find the Z, and then apply it. So let's look at how they ask the question, in what form they ask the question. So that this one says, for a medical test, there is such a wishes to select people in this middle 60% of the population based on blood pressure. Let me make it big. Based on blood pressure. Okay. Now, if the mean of the mean systolic blood pressure is 120 and the standard deviation is 8, find the upper and lower readings that will qualify people to participate in the study. Okay. Now, you have the mean are given, and the standard deviation is also given. So mean is this, and the standard deviation is also given. Now they gave you the probability. Okay, mean is, they say that mean is 120. Standard deviation is 8. I'm gonna make this to at least 14, so I can see it very well. Okay. Now they give us the probability again, 60%. So let us see how we can use this to get the lower and upper readings. First thing is to draw the chart. Okay. We have this insert the chart. Okay. Okay. Now, and then put the x-axis. Now, and then put the center line that represents the mean. Okay. And he said that for this test, select the people in the middle 60% of the population. So these are the middle 60%, middle 60%. Okay. And this one here, we say middle. The whole of this represents the middle 60%, the whole of this. That means they're going to be 30 here, 30% on the left side, 30%. And then on the right side, 30%, making it 60% middle. So that is the area. So we are looking for, in that case, you're looking for the X1, and which is the X1 is the lower reading, X2 is the upper reading. Okay. Now, so that means we need to find the Z1 and Z2. So the middle 60%, when you share it, it's gonna be this form. Because that is what we're looking for. We're gonna share them to show that that is what you're looking for. The middle 60%. Okay. All right. Just a minute. With it's always a challenge to do it this way, to draw this manually. But it's still not too bad. Anyway, last line. Okay, this is the middle 60%. So I'm sharing last line with this one. Okay. Now, so we need to get the Z1 and Z2. And this is our X1. So our Z1 will be, now it's a 30% on left side, 30% on the middle. So the two of them together make it the middle 60%. So let's use one half of it. Now they give us the, from here, on this line here, to this part, is 30%. It's not like the other one we did, where it's at the tail. In that case, we're looking, you have the whole of this, and we're looking for this part where we have to subtract from 0.5. In this case, we don't have to do that because it's started from 0 to this part, and it says 30%. So the Z1 is 30%, which is 0.3. Yeah. Now, because of symmetry, that means Z1 will be the same thing as Z2, except that Z1 will be negative to show that it's on the left side, and Z2 will be positive to show that it's on the right side. So let us find the Z1 first of all. Okay. We'll look for this on the table of normal distribution, 0.3. If you don't see it, I will use the one that is closest to it. Okay. 0.3000. So you go to table of normal distribution. 0.3 will be around here. There are two numbers that are closer. This one is close, and this one is closer. So let me write the two numbers down. 0.2995 and 0.3, and then that's this one right here. 0.2995. This one is 0.3023. 0.3023. So look, I'm gonna write them down so you can see. Let me try this one. 3.300 minus this one. 0.3. So I'm gonna look at them as whole numbers. So 3000 minus 2995. I got 3000. That is 0.3 minus 2995 is 5 points away. Now let's check the other number. The other number will be is 3025, 0.3023. This one you can even see it from here. It's 23 points away. 3023. We go to calculator. We have 3023 minus 3000. That is 23 points. So the other one is closest. So we're gonna use that. When I say the other one, I mean 0.2995. So we're gonna use it. 0.2995 is closer. We follow it to the left. 0.8 and up 4. 0.84. Now, because it is on the left side, Z1 for X1, see? Now, it's gonna be negative 0.8584. Now, Z2, which will represent X2, by symmetry, will be 0.84.
We still see the chart page. We don't see what you're typing.
This is the chart page. Okay, this one. Okay. Can you see it now?
No, we still see the chart.
Let me see what happens. Just 1 minute.
And now I can't hear you.
See it now?
You're like really low.
Can you see it now?
Yeah, we can hear you now.
Okay. Now, these are the two numbers we are looking for. Let me show you where we are. Say 0.300. This is 30%, which is 0.3, because there are 4 digits, is 0.300. Okay. Now we see that we look at the chart. We have these two numbers that are closer to it. The first one is 0.2995. The second one is 0.3023. So we use the one that is closest, which is this one. How? Because when you go to the calculator and do 300, which is 0.3. So
Yeah, we got that part. We got that whole part. We were at when you went to put it on the Word document.
oh, okay. So
Like we were where you got the 0.84 part.
oh, you saw that
Yeah,
part,
we
yeah?
saw all of that. Yeah.
So now what part didn't you see now? The when I was trying to put
We didn't see when you started typing it in the Word document. It was stuck.
okay, I see. Okay. Okay, now so 0.84 is I just typed it in 0.84. Now because it is on the left side and this one represents the S1, so it's negative. Now for the second part, Z2, which is for S2, by symmetry, it's going to be something 884, but now positive because it's on the right side. Okay, you saw that part, right?
Yeah, we're good.
So now with this, now we have the mean, we have the standard deviation, we have the Z for the two sides. Now with this, we are ready to plug in the formula. The first one is, remember, it says find the upper and lower readings. So the lower reading, which should be the X1, will be okay, equals to Z1 times standard deviation, which is which I can put from here, then plus the mean. So Z1 times standard deviation plus the mean, which is the Z1 is negative 0.84 times the standard deviation of our standard deviation is 8 plus the mean is 120. So we can now look at the calculator and put them in. Let me just write it down. 84 plus times 8 plus 120. Okay. So you have it in this form. Yep. Make sure I have this. Okay. All right. Let's go and put it in. 0.84 negative 0.84 0.84 times 8, okay, plus 120 is 113.28. 113.28. Okay, we have Let me go and put it in 113.28. Okay. 113.28. Then the upper reading will be x2, which is the same thing, except that now this time it's gonna be with positive number times standard deviation plus the mean, okay, plus the mean. So in this case, it's gonna be positive 0.84 times 8 plus 120. So we go there and then put it in at the calculator, and we get our answer right away. So it's right here. So we just take off the negative sign, and to give us the right answer. 1.2, 126.7 to 126.7. So we have 126.7. So this is the lower reading, this is the upper reading. Any question on that? Any questions?
No question.
Now, let us round up this by normal distribution by looking at central limit theorem. Now, what central limit theorem is saying is that as the sample size increases without limit, then the shape of the distribution becomes normal. It says, as if you have a population, according to what the way I put it here, with a mean of mean, mu, and standard deviation, delta, and take sufficiently large random sample from the population with replacement, then the distribution of the sample mean will be approximately normal. It will be normally distributed so long as it is large enough. So what this means that the application of this central limit theorem that we now introduce, if you remember the formula we used yesterday for transforming the variable into normally distributed variable, this formula here, what the central limit theorem means that we are going to introduce the sample size here and the sample mean, this formula, and then we'll be able to, that's how we use the central limit theorem to solve problem. Because then I see that as the sample size increases, telling you that you're gonna introduce sample size. And then means find the mean of the sample. So the sample mean will be approximately normal, so long as the population is large enough. So the formula we use for the central limit theorem, let me show you, take you to the other workbook so that I can put the formula in. The formula we use here will become in this form. The Z equals becomes have the sample mean, okay, with my equation. Okay, right here. The sample mean, which is you can get from here. Okay. Okay, this presents the sample mean minus the population mean, which is the you can find from here, I believe, right here, divided by standard deviation over the square root of n, standard deviation of delta divided by square root of n, with n. Okay. So now instead of x minus mean over standard deviation, we now have the sample mean and the sample standard deviation and the population standard deviation. So let me copy this and put it in the formula, and then we'll solve an example with that. Okay. So we're going to be using this formula here. So that's this. central limit theorem, when we want to apply it, we use this form to solve the equation. We use this formula here. Okay. So this formula S bar represents the sample mean. Then of course you know that this is the population mean. Standard deviation, square root of n. N is represent the sample size. Okay. Now, how do we figure this out? Let's look at this example here. It says, okay, now it says AC Nielsen reported that the children between age 2 to 5 watch on average 25 hours of TV per week. Assume that this variable is normally distributed and the standard deviation is 3 hours. If 20 children between age 2 to 5 are randomly selected, find the probability that the mean number of hours they watch TV. See, the mean number, that's the sample for this sample of 20 children, the mean number, which is the sample mean, see, the mean number they watch TV will be greater than 26.3 hours. So it says here, it says that we should assume that the variable is normally distributed. Solution. Now, so the first statement says that the Nielsen, this is I think is a market survey company, reported that children between age 2 to 5 watch on average 25 hours of TV per week. This is for the entire population. Children of that age, that means for the entire population, which give us that the sample mean, the population mean is that value. Population mean is 25 hours of TV. Then the standard deviation, I think that the variable is normally distributed and that the standard deviation is 3 hours. Okay, it's 3 hours. Now, they selected a sample of 20 children, and it was 20 children. And for this sample, the sample means out of these 20 children, the sample means they asked to find the probability that they watch more than 26. They spend 26.3 hours a week watching TV. Okay, so the sample mean, how we put it, let me, I have to get it from the formula, 26.3. Let me go back there and put it on. Sample mean will be 26.3 X bar, and sample mean 26.3, I believe. Now, I'm gonna copy this and put this right here. Yeah. So we have everything with us. So we have the mean. I'm gonna make this thing a little bit big. At least 14. Good. Mean and standard deviation. Now, you have the mean and the standard deviation, sample size, and so they ask you to find the probability that they of these 20 children, that the mean number of hours they watch TV is greater than this. So the first thing is to do is to transform this from X to Z. So now how do we transform it? By using this formula here. So once we transform it, then we can get our Z. It will no longer be here. So let's transform it. Let me write these numbers down. We got okay. All right, we have just plug it in. We're going to plug them in. So let me write them down then. 26.3 and 25 over 20. Okay. So now that means when we go to there, anywhere we see X bar, we put this 26.3 for X bar, 25 for the mean, standard deviation 3, and sample size is 30. So I'm gonna put it in. Have Z equals have than 26.3 minus 25 divided by standard deviation of 3 divided by square root of 20. So now we can put this in the calculator and get the answer right away. So let's put it in the calculator. Put the answer right away. So we have sample mean 26.3 minus population mean of 25 divided by standard deviation 3 divided by square root of n square root of 20. Then we close this from here. The 1.9379 is, continue, but we're going to stop at the second decimal place, 1.94. 1.94. So we have 1.94. In 1 minute, let me check something here. Okay. Looking for this approximation. Just 1 minute. Anyway, so we're almost there. 1.94. We have put it right here. 1.94. We're almost done. We're done. Just in a few minutes we'll be done. Now, you can see that it is no longer X bar, it is now Z. It is no longer 26.3, it is now 1.94. So we have transformed it. So the probability that the sample mean will be greater than 26.3 hour becomes the probability that Z becomes greater than 1.94. So the probability we're looking at for now becomes I hope you can see this. Yeah, sure. Okay, probability of Z greater than 1.94 now equals, so let me make it bigger so you can see it well. Make it 14 or 16. So now to find this probability, we make our chart. In the chart, we can now 1.94. Let's put the chart right here. I messed up. Okay, let's try it again. Here's the chart. So that we have, I'm gonna move it up a little bit. Okay. Good. Better that way. Now we're gonna put the x-axis. So I'll put it right here. And the line at the middle, presenting the mean, so that we have our 0 here. 0. Now, the probability we're looking for is 1.94. That means we're going to shed this part right here. So it is at the tail. So notice that whenever it's at the tail, whether it is a left tail or right tail, and if you're using this table that I'm using, the one I recommend for you, you're going to subtract answer you get from probability from 0.5, and then you get your answer. Okay. Now, let me just shed it so you can see that the shaded part is the tail. Okay, last one. So this is the probability. So remember, the halfway is 0.5, but you're looking for only this part. So you're gonna do 0.5 minus 1, sorry, minus whatever answer you get on the chart for 1.94. So for 1.95, if we look at the table, we go to our table, normal distribution table, 1.9 under 4. So 1.9 right here. See the Z, and you have to go under 4. So 1.9 under 4. See, that will be 0.4738. 0.4738. 0.4738 equals, when you subtract this on a calculator, 0.5 minus 0.4738. 5 minus that. So which we can get from our decimals, 0.5 0.5 minus 0.4738. 0.4738. 0.0262. 0.0262. So going back to put it on the chart, you have 0.0262. So the probability that for this sample of 20 children, that the mean number of hours they watch TV exceed 26.3 hours is 0.0262, which is something as saying 2.62% chance. Any question before we leave?
No question.
No questions.
Hold on, let me put down your attendance. So just keep on trying. As long as the score attendance is up to 80% by the end of this semester. Remember what we agreed on. So let me take it down. I have 2 of you here today. Okay, only 2 of you here today. So I got an A and Aaron. All right. You all have a good weekend.
You too. Thank you.
Yeah, me too.
Okay, bye-bye.